A black hole is a region of space where the gravitational pull is so strong that nothing, not even light, can escape. They are formed when massive stars die and collapse in on themselves. Black holes have three main characteristics: mass, charge, and angular momentum. The most common type of black hole is the non-rotating, uncharged black hole, which is described by the Schwarzschild metric. Other types of black holes include rotating, Kerr, black holes and charged, Reissner-Nordstrom, black holes. Black holes are invisible, but their presence can be detected through the effects of their gravity on nearby matter. Astronomers have observed stars and gas clouds orbiting around invisible objects, which they believe to be black holes. They have also been detected through the effects of their gravity on the paths of nearby stars and the distortion of light from distant objects. Although a black hole is invisible, scientists have been able to create visual simulations of how they might look. These simulations are based on mathematical models of black holes and the effects of their gravity on nearby matter. It is important to note that creating a video of a black hole would be a very complex task, as they are invisible and the only way to visualize them is through simulations and mathematical models. And also it is not possible to directly observe a black hole, but scientists can study the effects of their gravity on nearby matter to learn about their properties. A black hole near a star could have a variety of effects on the star, depending on the distance and mass of the black hole. If the black hole is close enough, it could pull material from the star, creating an accretion disk around the black hole. This can cause the star to brighten and flicker as material is pulled away. If the black hole is close enough and massive enough, it could also disrupt the star's orbit, potentially causing it to collide with the black hole or be ejected from the system. Additionally, the intense gravity of a black hole can also cause gravitational lensing, which can magnify or distort the light from the star. If a black hole were to come near Earth, the effects would be catastrophic. Black holes have extremely strong gravitational fields, which would cause the Earth and other objects in the solar system to be pulled towards it. This would cause massive tides, earthquakes, and volcanic eruptions. As the black hole gets closer, its gravity would start to disrupt the orbits of the planets, potentially throwing them out of their current positions. If the black hole was close enough, it could also start to pull material from the Earth, such as oceans, atmosphere and the solid Earth. This would create an accretion disk around the black hole, which would emit intense radiation. The intense gravity of a black hole can also cause gravitational lensing, which can magnify or distort the light from the Earth, leading to strange visual effects. Eventually, the black hole would likely swallow the Earth entirely. However, it's worth noting that black holes of such massive proportions that can swallow entire planets are extremely rare, and the likelihood of one coming close to Earth is almost impossible. There are several known black holes in the Milky Way galaxy that are relatively close to our Sun, but none of them are actually near enough to have any significant effect on our solar system. The closest known black hole to our Sun is V616 Monocerotis, which is about 3,000 light-years away. It is a stellar black hole, which means it formed from the collapse of a single massive star. Another known black hole is GROJ 0422+32, which is about 4,000 light-years away. This one is also a stellar black hole. There are also several intermediate mass black holes that have been discovered in our galaxy, but they are all much further away, on the order of millions of light-years. It's worth noting that black holes are invisible, so they can only be detected by observing their effects on nearby matter. Therefore, it is possible that there are other black holes in close proximity to our Sun that have not yet been discovered.